now we kind of like have a light at the end of the tunnel in terms of the vaccine, but it's kind of confusing because there's all these drug companies with different kind of vaccines. You've got the Pfizer one, the Moderna one, AstraZeneca one, got Oxford University's own one, and then you got the Russian one, Sputnik, I think it's called. The Chinese have one. Who else got one? Is I think President Erdogan's got one or something like that. He was, I don't know. I saw some article on Facebook. Apparently, Turkey's got one as well. President Erdogan. Yeah, it's kind of why do you need so many brands of vaccine? Is it like it's like Coke, isn't it? You got Coca-Cola, Pepsi, and then you got all these other Sainsbury's cola. Is it like that? It's the same drink but with a different label.
The washing powder effect. You walk down the washing powder aisle in the supermarket.
Yeah.
And you're surrounded, overwhelmed by the choice that you have.
Yeah. Is it like that? Do they just basically do the same thing, but it's like one's more expensive than the other? Is that what it is? And you always go for the expensive one?
So I think there's another element in this, right? There's a benefit in having that diversity. Because the more ways we have, the more suitable they are to the diversity of any human population. There will always be people who are unable to have one kind of vaccine, or in whom a vaccine may work less effectively.
But isn't it the same thing? Isn't it like paracetamol in the sense that it works the same way? Or do these vaccines work in different ways? Is that what you're saying? And different people need, because of their condition, they need a certain type of vaccine. So is that what it is? So are we saying a vaccine is like a painkiller, but you have, because of the injury that you have or the health conditions that you have, the doctor prescribes you a different type of painkiller, like a paracetamol or ibuprofen or Panadol or Cocodamol, or morphine, for example. So you have, so is a vaccine like that in the sense that you have, you want to basically eliminate the virus, but because of underlying conditions of a person, you have to use a different method to eliminate the virus. Am I correct in that analogy of it?
I think you're pretty much saying what we think on this book. But I think it'd be useful just to roll back a bit and just think about what a vaccine is, right? Vaccine, an immunization, what are they? And let's play a thought experiment. Go back 300 years to rural Bengal. And you have a society in which there are regular outbreaks of an illness called smallpox, a debilitating, destructive, fatal illness.
Leaves a scar as well.
Characterized by...
And I have met people with smallpox scars, very old people. Yeah.
Okay. So it's a scar that lasts for life.
Yeah.
And it's a scar, it's a disease that, although more prevalent within congested, poorer communities, affects anyone and everyone. Almost like what we're looking at now, right? That you're less likely to survive if you're poor, you're more likely to get it if you are, but anyone can have it. And it marks the way whole societies think and how we relate to one another, who we touch and who we feel, who we accept and who we reject, who we isolate in this. And for many years in the United Kingdom, there was no way of treating this. There was no way of dealing with it. But in the Gangetic Plain, in Bengal, and what is today Bangladesh, there was a group of people, probably maintained by funds from local rulers, so entrenched within society, whose role was to go around and reduce the severity of this disease by immunizing the population, by creating an immunity within the population. They did this by giving a weakened form of smallpox to cause an infection to prevent a severe one occurring. And it was finally introduced into London by a lady called Mary Wortley Montagu, who, following a stay in Constantinople, Istanbul, as the wife of the British ambassador, saw the same practice occurring within Istanbul. So this is a practice that's common through what is today seen as the Muslim world. In an attempt to change the immune response to an infection and to generate immunity and protect the individual and the community as a result. Now, the destruction of this and then the resurgence of smallpox within Bengal following East India Company rule and the undermining of traditional structures is another story. But this illustrates the fact that our human attempts to control how infections affect us is something that's part of our story. And that's what a vaccine does, what an immunization does. It attempts to generate an immune response by exposing the immune system to an element that it sees as being foreign.
So what you're saying, vaccination has been around historically. It's not part of something that's come up by the military industrial complex. There's this video going around where I think some Belgian homeopathic doctor was saying that it's got some gel in there for mind control. So what you're saying is that what Umar is saying is vaccination as a method has been around historically. It's not something that came out of big pharma. It was before modern medicine or modern industrial medicine as a method of coping with outbreaks of diseases in Bengal or Istanbul, and then brought into Europe, etc. I think indigenous tribes, have their own forms of vaccination. I remember watching something about penicillin. Was Aboriginal tribes used to there was some fungus or something like that they used to put on their wounds, and it's from that. So a lot of modern medicine is actually medicine that's been around for a long time, but someone's figured out how to make money out of it. That's my understanding of it. A lot of this stuff used to be free, and then someone just patents it and makes money out of it and industrializes it. So that's probably the same with vaccination. It's been around. It's been around before 5G. I know there's some guy with a video saying the gel from the vaccine and the 5G will control us, but this has been around. So I just wanted that's what he's saying. Guys, yeah, you can watch those videos, but you can watch this video and then you can make your mind up, kind of ish. Sorry.
No, not at all, Puru.
Yeah.
So the whole purpose of immunization is to generate immunity, is to enable your body to overcome an infection when it encounters it. And the way to do that is to introduce the body to an element of the thing that causes that infection, so that it has a chance to test itself out against it.
So the other thing is the other thing is that it's not going to mutate our genes or nothing like that. This is just a weaker form of the disease, so we get infected anyway. So this immunization is you get a weaker dose to build up your antibodies. It's not like something's gonna.
So
like X-Men, like X-Men, like something. You see the cartoon, something happen, and then everybody starts getting superpowers. It's not like that. It's just a milder form of the disease. I'm just telling you, this is what some people have told me, that is this going to affect our gene pool? I'm like, good question.
We'll come to that in a moment, because there are several ways in which you can introduce the infection into your body in a controlled manner to cause an immune response. So a lot of these infections, the infections that we look at, are caused by viruses, by bacteria. And most of the immunizations that we have available to us help in preventing infections by these viruses or bacteria. So what are you trying to do? If you think we're all made up of different kinds of chemicals as part of us, right? And one of these is the protein. And viruses and bacteria have proteins. Viruses, if you like, are these protein packages. It's almost like a football or one of these toys with multiple surfaces, polygons, that have lots of proteins on the edge, and they have bits poking out. You may have seen the pictures of the coronavirus with its spike protein sticking out to the surface, and with structure at the end that can clasp on to another protein that's normally part of our cells, and then gain entry into a cell. And once it gains entry into a cell, then it starts replicating. And as it replicates, it causes all kinds of havoc and damage within the cell, and ruptures, kills it off, and then comes out, and then finds another cell to go into, and the process continues. And that process of propagation, replication, cell destruction causes illness in us. So to stop it, we have a lot of effort devoted to seeing what's the best way of stopping this virus getting into our cells. And what people have focused on is that spike protein, that arm with a clasp at the end, right? And how do you get the body to recognize this thing? And how do you then get it to produce antibodies to this?
To attack it, basically.
Exactly. So you imagine that the virus is some kind of stealth bomber flying through the air. And what you need is a way to reveal it.
Gotcha.
And one of the ways of revealing it is to sprinkle this kind of dust of antibodies over it. That then enables you to see where it is and allows the body to attack it and remove it from circulation. And one of the key points about the immunization is that it's trying to create antibodies to this spike protein. And it's also trying to enable to get the body to recognize it, so that the cells, the white cells within the body that scavenge all of this material, will be able to come in and, almost like Pac-Man, chomp away at it, right? And get rid of that, and get rid of anything that has it on it. The things that will have the spike protein on it will be the virus.
Gotcha.
How do you expose the body to the spike protein? You can inject spike protein into the body.
Like a weaker form, basically.
And I think that's what the Chinese are doing. What you can also do is try and get the body to produce this spike protein.
Okay.
And in that way, you only have to introduce a small amount of the starter material.
Is that what the Russians are doing? Is that what the Russians are doing?
That's what the Russians are doing. And there are several ways of getting the body to produce this. And I think we'll go back a bit here. You and I are made up of a fundamental unit, which is the cell, that defines biology, if you like. And in this cell is a section called the nucleus. And I think of it as a vast library. A library that we've inherited from our forefathers that we will pass on to our children, filled with volume upon volume upon volume that tells the body how to create proteins. Each book, a different kind of protein.
Is that what DNA is?
That's exactly what DNA is.
Gotcha.
And then when you need to produce the protein, you access the book and you copy that chapter or that book and you send it out of the library as a letter. That then goes to the place where the proteins are made and is the code that's used to code for the protein.
Gotcha.
Now, that letter is mRNA, messenger RNA. No matter how many times you put these letters together, they never make up a book. They have a completely different role. They're never inherited by the offspring of that cell. They never go from you to your children.
Got you. So that's why you need constant vaccination, generation after generation.
Well, we'll come to that in a moment. So when that letter is used, it's essentially burnt. It's destroyed. And instead you have the end product, which is the protein that's there. What a number of these vaccine strategies are trying to do is get your body to make some of that protein. One of the most direct ways of doing that is by injecting that mRNA, that letter, into your cells. So by injecting one copy, one letter, you can make hundreds, maybe thousands
Is
of
that
proteins.
what the Oxford University guys are doing?
So the mRNA is the Pfizer and the Moderna vaccine.
Okay. Gotcha.
Right? This is the vaccine that German-Turkish couple have gifted to the world, if you like.
Gotcha.
And another way of trying to get your body to produce that protein is actually to introduce the step just before the mRNA, right? But outside of the nucleus. So nothing to do with the nucleus. Tell me what happens to you when you're exposed to a virus, Puru? You breathe it in. What does it do? What does the virus do immediately?
You start producing. It has an impact. It produces a reaction in your body.
Exactly. So it produces a reaction in your body,
and you start producing fluids, etc.
So it
runny nose, a lot of phlegm.
Exactly. So all of this is a product of the virus being active within you. But what it does also is it gets into your cells. And viruses are very good at getting stuff into your cells. So instead of just fighting the virus, why not make use of that mechanism? So you deliver this into the cell,
Gotcha.
Just before the letter, not the book, just before the letter. Deliver it in, create more of these letters, and produce even more of these proteins. So that when that cell then exports these proteins out of it, the body's immune system sees them and recognizes that these aren't proteins that the body's producing normally, and it starts developing a way of controlling anything that has that protein. And you have an immune response.
Gotcha.
So you have the Moderna and the Pfizer route, which is to bring the mRNA in, that letter in, and inject it into the cell. Or you have the British and the Russian route, both using similar viruses. The British one using a monkey cold virus, which affects monkeys. The Russians using a cold virus, which affects humans. In order to deliver the code for the protein And these are viruses that don't reproduce.
Gotcha.
So they never change your own DNA.
Gotcha.
You never inherit this.
Gotcha. So, but for a